Okay, hi everyone. Welcome back to our Chapter 8 HL test review. This is the first question, and it says that the region enclosed between the curves y equals root x times e to the x power and y equals e times root x is rotated through 2 pi about the x-axis. Find the volume of the solid obtained. Now, we know that we're trying to find the volume of the rotated volume, volume of the rotated area between the two curves. So we want to define at which domain we're working with that has the area between the two curves. So I'm going to set the curves equal to each other. Y equals root x times e to the x power, which equals e times root x. If we divide both sides by root x, we get ex equals e, and to make that happen, x equals 1. X can also equal 0, since both sides have root x and root of 0 is still 0. And if you multiply both variables by 0, we get 0 equals 0. So now we know that the domain we're working with to find the area between two curves is from 0 to 1. Okay, now I want to find the volume each curve makes when it's rotated through 2 pi by the x-axis. And to find the volume of a rotated curve, we know that volume equals pi r squared, right? Times height. Now, if we're trying to find the derivative of those, because it's by a limit, we get our volume equals integration of pi, and r is substituted by f of x, which is actually the height of the curve, so f of x squared, and the height is actually the width of the rectangles we draw, but since the limit goes to infinity and infinitely small, then we can substitute that for dx. Okay, so to find the volume, let's call this volume 1 of y equals root x times ex. We need to integrate that. And to do so, I'm going to integrate by parts. So the volume is, we can move pi out because it's a constant, pi times integration of root x e to the x power squared dx, and simplify that, that's pi times integration of x times e squared, e to x dx. Okay, so now I'm going to integrate by parts, starting with x. To find the derivative of that is 1, derivative of 1 is 0. Now e to x, derivative of that is 1 over 2 e to x, and the derivative of that is 1 over 4 e to x. And so that's how we integrate by parts, and we plug that back in. Oh, also, I forgot that the domain of the integration from 0 to 1, as we found before. So that would be pi, volume 1 equals pi, times 1/2 e to x times x, this part, minus 1/4 e to x times 1. And that's from 0 to 1. Okay, now we plug in the 0 and 1, that we get 1/2 e to the 2 times 1 e squared times 1 is still 1/2 e squared minus 1/4 e to the 2 times 1. Now for a 0 part, 1/2 e to the 2x x, when we plug in 0, that's still 0, minus 1/4 e to the 2x is e to the 0, which gives us 1. So our volume of our first curve rotated about the x-axis is 1/2 e squared minus 1/4 e squared plus 1 over 4. I actually forgot to put pi here. We multiply everything here by pi, right? Let me scroll down a little bit. So actually our volume underneath the curve of our first curve rotated about the x-axis is pi times 1/4 e squared plus 1/4. Okay, now we're going to find the volume rotated about the x-axis of our second curve. So volume 2 equals pi from 0 to 1, integration from 0 to 1 of e times root x dx. Oh, e root x squared, I forgot that, because it's radius squared. So that's pi times the integration from 0 to 1 of e squared x dx. And when we do integrate that, that is just 1/2 e squared, I believe so, times x, because x is a constant from 0 to 1. My bad. Okay, my bad. X is not the constant, e squared is the constant. So we have e squared, right? And integrate x, that is 1/2 x squared from 0 to 1. Okay, now when we plug in 0 and 1, we get pi times e squared 1/2 1 squared, which is e squared times 1/2. And then when we plug in 0, it just gets 0. So the volume underneath the second curve rotated about the x-axis would be pi times 1/2 e squared. Okay, if you plug all this in the calculator, you would find that the second volume is greater than the first volume. So we're going to subtract volume 1 from volume 2. So we get pi of 1/2 e squared. I can take out pi from both sides. Minus 1/4 e squared plus 1/4. And that gives us pi times 1/4 e squared minus 1/4. And if we take out 1/4, we get 1/4 times pi times e squared minus 1. And that is our answer to our first question.